Greetings. Today we are just going to touch upon functions, the basics of functions. We'll be learning things like what is a function, what does a function do exactly, how do they come about creating functions in maths, so that next time when they ask you a question based on functions, you know how to approach the question, you know how to approach that question, how to answer the question, because you see, sometimes the problem is that when they ask you a question, you may not know where to start, how to go about thinking of it, and things like that. So before I begin, let me just reveal a few things about functions. Let me just reveal a few things about functions. So number one, when you're talking about a function, you're talking about a relationship between x and y. A function is simply a relationship between x and y. So what they did now was, because they realized that they could make y the subject of the formula and do whatever they want to x or with x. You can put x as an exponent, you can make it as a division, as in you divide by x, you can multiply anything by x, you can make x squared, cubed, whatever you want to do with your x. They said y is equal to whatever type of nonsense you want to put there multiplied by x or whatever with x. And every time you put x, a different x, you will get a certain y. But because now, they move in patterns. Like for instance, if you say y is equal to 2x, every time you put value 2 on x, you're going to get, your y value is going to be twice the value of x. And so because of that, and because the pattern, the sequence is linear, yeah, you see in grade 12, there's sequence and series. Because the sequence is linear, it therefore gives you a straight line. That's because it is linear. You see, it gives you a straight line. If you do physical sciences and you do Ohm's law and stuff, you realize that when it's a straight line, it has to do with proportion, mostly when the gradient is 1. You see, when they see things are directly proportional or inversely proportional, which inversely proportional, yeah, it looks different, that one. Yeah, inversely proportional. Yeah, they're gonna look different, but I haven't really seen how inversely. Oh, it looks the same, but the other one is a reciprocal. But either way, yes. So let's just begin. Let's just begin. Uh, yeah. There. We are about to start. There it is. There it is. We are doing thing. What do you call? Mm. Okay, we are doing something just now. Just give me a moment. Give me a moment. Uh-huh. Okay, there it is. There we go. And there we go. Yes. We are doing functions today. Let's just see something about the linear graph. The linear graph. Let me quickly get my pen. Where's my pen, though? Where's this pen? It's the pen. Yes, my pen. Here quickly. Let me just, so that, damn, move. Okay, so this is what's happening now. The function that we have over here, okay, we have what you call a linear graph or a linear function. Linear. Linear means straight, in the same line. Many people prefer calling this a straight line because it's a straight line. I mean, you can see that this is just a line. But the question is now, how did they come about making things like these? How do they come about making a line? How do they come about making, where does this come from? Where does this equation come from? Y, is equal to mx plus c, yes. Now, remember, as I said, that they just made y the subject of the formula, meaning they put y, meaning y is equal to this side, there's only y. Thus, y is the subject of the formula, because with this entire formula, it is all about y. An important thing, I think you will need to write this down. You ought to know that y, when they talk about y, they are talking about a function. So generally, when they write things like f of x, g of x, h of x, k of x, m of x, t of x, or whatever they write, you better know that they are talking about the y value. So if they ask you, is this graph, where is this graph increasing, for example, where is it increasing? You're gonna check where the y values are. Okay, no, not increasing, not increasing. If they ask you where is this graph greater than 0, then you're gonna check where the y values of the graph are greater than 0. Usually they will ask you like, what are the x values when the graph is greater than 0, or the function? Then you say, okay, for instance, let's assume this straight line over here, the thingy, let's assume the intercept was 0, 0, the x and y intercept were both 0, 0. Then we'll say, okay, it is where x is greater than 0, because when x is greater than 0, even the y values are greater than 0. Yeah, you remember what I was saying about who's this that resistance guy, Ohm's law, about the proportion and things like that. Yes, the proportion that when for instance the resistance or whatever this is 2 times, even this one is twice. When things are directly proportional, we are saying that when this one increases 3 times more, even this one will increase 3 times more. This is where proportion comes from. Now, why? I'm not asking you a question why. I'm saying y is equal to mx plus c. C, which is our constant. But the question is now, okay, since our c is our constant, it's a number. It's always like that. So let's not worry too much about c. Let's worry about this mx. To say what's happening with this mx. Why is there m before x? So what does the m do? And if you can check, the m is the one that you calculate differently, because the m, when you calculate the m, you divide the y, delta y, by delta x. Delta means change in. So change in y divided by your change in x. This is what's happening now. We are saying we want the y values. We want y. And for us to get y, we have to substitute whatever x that we want to substitute. Now, in this particular equation, we want to know what x is, what y is in terms of x. What is our y in terms of this x? Which means, what is our y value with whatever the x value? Then we say, okay, first thing, x. We can see that, okay, over here, the coordinate here is 8 and 4. 8 and 4. Let me try to write it down for you. What is that thing? What is that thing? I want to write down. No, not this one. No, not this one. Ah. Oh, yes. Oh, yeah, it is. Let me see if I can write down on this thing. 8. Yes, x is not this color. Not this color. No. Yes, this color. X in this case is 8, as well as 4, right? We've seen that x is 8 and 4. I want to show you something about gradient, so that next time they ask you questions, you don't get confused. You'll know what gradient is, what they are asking you exactly, so that you answer correctly. You see, it is very important. Yes, let's say here's the coordinate. Here's the coordinate. No, where's my pen? Where's my pen? Pen. Yes, I found it. I found it. Here's my beautiful pen. Now, the reason why, now what we do, because remember now, when you say delta y, we're gonna say this 4 minus this 2, right? 4 minus this 2. It's because we are trying to get the distance over here. The distance over here, it is this very distance that's over here. This distance. Remember, it is a thing like this, for instance. There is this over here, this distance over here between this 4 and 8, and there's also that distance over there between the 4 and 2. Okay, let me try and maybe put a line here so that you can see something here. Yeah, so let's just put a simple line over there. Let me get my pen again. Yes. What you are doing now is you are saying to yourself, okay, what is my y value? y is equal to mx plus c. Then you say, okay, what is the ratio, or how does y change in terms of x? Or what does y do? How does the x value, how does the x value influence the y value? You say, okay, let me check how many more times is x in terms of y. You see, how many more times, how much more? Then you say, okay, my change in y in this case is 2 because 4 minus 2 is 2. My change in x, 8 minus 4, 8 minus 4 is 4. Then you say, okay, the question is now, what is the ratio between y and x? What is the ratio? What is the ratio between y and x? Then you say, okay, delta y, which is 4 minus 2, you know, you get your 2 divided by your 8 minus 4, you get your 4. 2 divided by 4 again, which means this is how ratios work, by the way. When you check into a ratio, you're saying that 4 minus 2, you know, divided by this minus that, which generally tells us that, okay, you are saying that your y value is 2 times, I mean, if your y value is 2, then your x is 4. You see, if your y value is 2, but you want the simplest ratio because for whatever y value, twice the y value, it has to be 4 times the x value, but you want a simple ratio. So you're going to divide by that 2 again. That's why we will generally say 4 minus 2, which you get 2 divided by 8 minus 4. 2 divided by 4 is the same as saying, because remember you divide by 2 on both sides, you get 1 divided by 2. So which means our y values are, our x values in this case are twice our y values. It is like saying 1 is to 2. This is what we got here. 1 is to 2. That's our ratio. That's our ratio. 1 is to 2. Because for every time your y is 1, your x is 2. Which means if your y was 50, that means then your x would be 100. Because you see, over here, your x is 4, your y is 2. Over here, now your y is 4, your x is twice that value. Your x is 8. When you calculate the gradient, generally you will say half. I mean, you will say half. You will say, okay, y value is equal to half times whatever the x is. That's what you are saying. It is equal to half times. Normally, we would say x divided by 2. Then we say y is equal to whatever this is divided by 2. So y is equal to mx plus c. Normally, we'll say, you know, y is equal to, if your x is 8, for us to get our y over here, we have to divide our x being 8 by 2, divided by 2 to get the y. Because remember, if this was a walking slope, you would say, I've traveled 4 meters horizontally. On the ground, I've traveled 4 meters and I've went 2 meters above, for instance. So which means for every 4 meters that I travel high above the ground, I mean, for every 4 meters I travel on the ground, I travel 2 meters above the ground. You see, for every time y moves 4 times, I mean, x moves 4 times, y moves twice. So which means whatever the x value is, whatever the y value is, being multiplied by 2 gives you the x value. That means whatever the x value is, being multiplied by a half will give you the y value. Now, where does the half come from? Remember the reciprocal. You can, if you divide by a number, you can multiply by its reciprocal. You see, so which means if you say you know, 4 divided by 2, because remember now your x is 4, and for you to get the y, you have to, well, multiply it by 2, which means yes, now we are dealing with y here, which is the subject of the formula. In this case, your y is 2. So 2, for us to get our x, we have to say 2 divided by 2. In this case, our x would be, no, wait, your y value in this case is 2. And then your x value is 4. How do we get 4? It's because your x value is twice that y value, which means we would say if our x is 4, In this case, our y value is 2. What happened was that you would say, generally you would say 4 divided by 2. You see 4 divided by 2 in order to get your y value of 2. Otherwise, if you say your y value is 2, then 2 would be equal to half. I mean, 2, yeah, 2 would be equal to mx, right? In this case, our x is 4. So which means 2 is equal to half multiplied by 4. Or 2 is equal to this 4 over here being divided by 2. Because remember, 2 is equal to 4. 4x, which is 4, divided by 2. Right? Okay, let me start afresh. 2 is equal to 4 divided by 2, right? The question is now, if you write something like 4 divided by 2, what else can you do? You say 4, 4, divided by 2. Yeah, it looks like I don't have a division line. Do I? Do I have division? It looks like I don't. No, I don't. Okay, it's fine. 4 divided by 2. We can also say 4 multiplied by the reciprocal of 2, which is generally 1 over 2. The reciprocal of 2, right? That's why when it comes to gradient, we don't always have to say x divided by 2. We can just say a half multiplied by x. You see, so in this case, your equation is y is equal to half times x. That's your equation. And then your c would be your y-intercept. If you really want to get your c, you would have to substitute a point. Let's actually find out what the c is in this equation. Yes, let's find out what our c is. We want to substitute 4 and 2. You can substitute any point as long as you have a gradient. You can substitute any point, it doesn't matter. You are saying, okay, 2 is equal to half. We did establish that it is half, half times, in this case, our x is 4 plus c. This is where many gradients get confused. The gradient, the gradient. You have to get the gradient and a point. You have to, once you have those. Otherwise, if they give you c and they give you a point, you can also use that to get the gradient. Yes, you can. It is possible, but my big advice is use any 2 points in the graph to get the point. But otherwise, mathematically, you'd still be correct. Now, let's see. 2 is equal to half times 4. What's half times 4? Half times 4 is the same as saying half divided by a quarter. Okay, let's not do that. Half times 4 is 2. Oh, you can also say 4 times half, which is the same as 4 divided by 2, because you can divide by the reciprocal. In this case, it is 2. And then take it over to that other side. Remember, you're going to have 2. You're going to have 2 is equal to 2 plus c. And then take it over to that other side. In this case, you're going to have 2. Remember, it changes sign. So 2 minus 2. Don't panic. Don't panic. Don't panic. Is equal to 0. 2 minus 2 is equal to c. 2 minus 2 is 0, which means your c is equal to 0. Now, what does this tell us? This tells us that this whole graph, let me just check something quickly. This tells us that this whole graph intercepts the y-axis and the x-axis over here. That's what it tells us. No, the y-axis. Because remember now, C is the addition or subtraction of the original y values, which means generally we are dealing with y is equal to x. Y is equal to x. This is what we are dealing with. This is what's important in this equation. That's why they call C a constant, because it never changes. And just leave C like that. We are not dealing with C. This is what's important. Y is equal to mx. Now, generally, we would say y is equal to x, but, we change the gradient. We say y is equal to, this time around, I want my y value to be equal to 2 times the value of x. 2 times. And it gets confusing when you say for every 2 steps, you move up, or for every 1 step, you move up, you move 2 steps right. Yet we are multiplying and we are not dividing or making ratio. But Believe you me, it is, remember our ratio in this case was 1 to 2. So for every time you move once with the y value, you are moving twice with the x value. But because it's math, we want to know how many times the x value is in comparison to y. You can make it as much times as you want. You can say y is equal to 1,000 times the value of x, which means whatever x value is multiplied by 1,000 in order to get your y. You can say y is equal to 2 times the value of x, whatever the x value is multiplied by 2. Every time you move forward, if you moved 4 times, you moved 8 times above with your y values. You see? So whenever your y values became, your x values became whatever amount, your y values had to become 2 times whatever those values are. This is where gradient comes from. Gradient, it is the ratio between the x and the y values. That's what you call gradient. Gradient. Gradient is the one that tells us how steep the slope is, how steep it is, or how gentle it is. In geography, they will say it's a gentle slope. If you were on a mountain bike and you were to go above the slope, you would really struggle because it is quite gentle. No. Actually, you wouldn't struggle much because this is actually a gentle slope. It is not drawn up to scale. It is not drawn up to scale, but this is actually a gentle slope because the gradient is half. The gradient is half. You see, the y value is equal to half times the x value. So which means whatever y it is, if your y is 2, that means your x value has to be 1. You see. No, actually, yeah, I would say, let's see. No. If your x value is 2, your y value is 2, then your x value is 4. Yes. Which means if your x is 8, 8 multiplied by half, 8 multiplied by half, or 8 divided by 2, then your y value is 4. Yes. Yes. So it is very gentle. For every time you are working twice over here, every time you are working twice over here with the x, you are only working once with the y. Every time you are working twice with the y, you are working 4 times with the x, which means for every one step that you take of y, you just took 2 steps with the x, 2 steps of the x values, 2 steps on the ground. For every 2 steps you moved above the ground. Pilots will say altitude and things like that. If the gradient was 2, you were gonna say for every 2 steps that you took above the ground, you took only 1 step on the ground. Or for every 1 step you took on the ground, you took 2 steps on the ground. See, okay, we've got this equation and things like that. See, we are just moving it upwards from this origin, 0, 0. We're just moving it upwards or downwards. We're just playing with it. See, we are just moving the graph up or down. We are moving it up or down. That's what C is for. Think of it like this. Y is equal to mx. Then we decide to say, okay, y is equal to whatever times the value of x. But because everything here was moved, however times upwards, plus whatever that is, or minus c. But the reason why I will just write plus c is because if your c is -2, plus positive times negative will return a negative. But if your c was +2, positive with that +2 of c would return a positive. That's why you write it like this. Y is equal to mx and then plus c. But mostly they will say plus minus c. I don't, yeah, but so yeah, you are just adding. This is how this one works. Okay, I think you are ready to move to the next one now. The next one, which is our thingy, what you call? How is it not moving? Is it not moving? Okay, we are gonna move to our next thing just now. Okay, come on now. Just technologies. Okay, do the right thing, do the right thing, do the right thing. Mm-hmm. Mm-hmm. Now we are moving to a parabola. Yes, yes, yes. There we are with the parabola. Oh, let me check something. Mm, okay, no, I see the mistake I did there. There we go, there we go. Let me just quickly get my pen again. Where is that pen? Pen. Ah, ah, where is this pen? Here's my pen. A parabola, on the other hand, remember what I said about functions, that it is just the y values. A function, it's just y is equal to whatever the x value is, with respect to it. When you're in grade 10, generally they will say the y-intercept is a turning point. Yeah, but this is for when you're in grade 10. When you're in grade 11 or 12, the turning point changes. You can have a parabola over here, or you can have it down there. Anything that looks like this is no, not like that. Anything that looks curly like this, like a smiley face, is a parabola. It doesn't matter where it is, it's a parabola. This straight line has an equation. Y is equal to 0. That's the equation of this line. And then this straight line also has an equation, x is equal to 0. That's it. The gradient for this one is undefined. The gradient for this one is 0. You see, so we are saying that y is equal to 0. X is an element of real numbers. Here we are saying x is equal to 0. Y is an element of real numbers. This is the range and the thing. I forgot to add the range and the domain, but I will explain the range and domain. It's not a train smash. I will just explain range and domain. How long have I? Okay. All right, let's proceed. This is a parabola, also called the quadratic because of the quadratic equation. Yeah, there's a cubic, there's quadratic. There's also that Pythagoras that you know of, which has to do with circles and things like that. But either way, this is a parabola. Y is equal to ax squared plus c. Now, I already explained what a does generally, because remember, when we were still in the thing, in the hyperbola, we said that this is whatever times the value of x. And behold, with the function, you can do whatever you want. You can say y is equal to, you can make your m anything, literally any number. You can make your m k. You can say y is equal to kx. Why did they make it m? They just chose m, but you can make it y is equal to 500x. You can make it y is equal to 2 billion x, 2 billion times x, which means y is equal to 2 billion x. Wow. So which means y is equal to 2 billion times the x value, which means for every time you move one step, for every time you move a billion times, you are moving one step with x, because if you say y is equal to 2x, you are saying that if your x is 4, y has to be twice that value, which is 8. So if you say y is equal to 2 billion x, you are saying that y, if your x is 1, then your y is 2 billion, because 2 billion times 1 is 2 billion. That's very steep, very steep. Honestly speaking, I would die. Let's forget about that 2 billion. I would die. Yeah, I would die. No, you won't even try that steep. You know what? Forget about it. You won't try it. You won't try it. Even if you are good on a mountain bike, you will. Oh, what is this? Made a mistake. You won't get it. You won't get it. Come on, come on, come on, come on. I don't need you anymore. Yes, you won't get it. So forget about it. But as we are saying, yes. So which means if your x is 1 and your gradient here is 5, y is equal to 5 times that 1. So yeah, remember what we said here. You can multiply x with anything, but you can also do whatever you want with x. For instance, um, oh yes, okay. For instance, x squared, x squared, y is equal to ax squared plus q. Forget about this again for now. This, you don't worry too much about it. This part over here, y is equal to anything here that is x, is what you should worry about, because we are trying to find the relationship between y and x being squared, x being squared. Now you will understand that for every one y value, for every one y, like over here, you see it's one y value, you got it returned two x values in a parabola. It does not return one x value, and there's a reason for that. Remember, I'm just explaining the basics, and the concept behind this, so that when you get to questions, you'll understand how we go about interpreting questions, so that when they ask you, for instance, what are the a values where this whole graph, I mean, what are the x values where this graph is undefined? Then you wonder, where is this graph undefined? Where is this graph undefined? There are no x values. So which means x is not an element, x is an element of non-real numbers, because there are no x values where this graph is undefined. But if I start to ask you now, what are the x values where this graph is let me see. Let's say we had a coordinate. Let's just play around something. Let's just play around something. DLM Christian. Okay, good shot. Good news, but it's fine. Let's say this equation was our x in this case is 0, because it's a turning point. It's a turning point. Our x is 0 and our y is 5. No, you want to get level 7, so our y is 7. Yes, we are getting level 7 this year. Yes, our y is 7. Let's play around. Let's play around. Let's play around. We are doing this. We are doing this. Okay. And then I ask you a simple question. What are the x values of this graph where y is greater than 7? Then you say, okay. What are the x values? What are they? This is how you interpret the x values. You check everywhere where y is greater than 7. You check, okay, y is greater than 7. The moment y is 7, your x is 0. The moment now, because remember from here, the graph becomes greater and greater. It does not become lesser and lesser. You see, it's facing upwards. So it has to become, the y values become greater and greater as it goes up and up. The moment the y values become greater and greater, the x values are becoming greater than 0. At the same time, the x values are becoming less than 0, because over here, the graph is greater. Over here, the graph is also greater. I mean, the y value is also greater than y. It is only here where x is 0 that y is equal to 7. So what do we say? We say, okay, okay, x is not equal to 0, therefore. Because for every time that x is not equal to 0, whether it is less than 0, whether x is greater than 0, your y is always greater than 7 there. This is how you interpret it. This is how you look up, you go about it. If I ask you a question like, let's say I ask you a question, for which x values is this graph not greater than 6? I mean, 10. For instance, I want to go through this quickly before I go far. Let's see over here, your y value in this case, your x is 0 again. Your x can be 0 in many cases, but your x is 0, but your y, no, wait, no, your x is not 0. Your x cannot be 0. Let's say your x is x, yeah, we haven't established the a value, so x is x. Then we say our y value is 5. Okay, 8. Yeah, it can be 5, so 8. It cannot be 5 because graphically it is incorrect. If it is 5, then how is this one 7? Unless the graph is upside down. Yeah, but maybe your eyes are upside down and you think it's upside down, but it's not upside down. or maybe my eyes are upside down. I don't know. -8. Yes, -8 over here. You will understand why it's -8 if the other one is 8. Okay, yeah, no, it's fine, it's fine. And then they ask you a question. For which x values is this graph smaller than 8? No, wait, this is 1. No, this can't be -8. Yes, this can't be -8. My word, I made a big mistake. This cannot be -8. Yes, this is 8 again. Oh, the x has to be, yes. The x is what becomes negative, which you will understand why. Here, yeah, x is positive. You know, x is generally positive there. So what we are doing now is we are saying, for which values of x is this graph smaller than 8? For which values of x is this graph smaller than 8? You're gonna say, okay, over here, my y value is 8, right? Which is over there, it is 8. Over here, it's also 8. We want the x values where it is smaller than 8, which is this space over here. How do I know it's this space over here? No, this space over here. How do I know? It's because my 8 is over here where I put this this line over here. So when it becomes smaller than 8, what happens to x? When my y value over here is 8, my x value over here was -x. When my y value over there is 8, my x value is x in this case. So which means my x, when my x becomes, okay, let's first check what happens when this x becomes bigger. When this x becomes bigger, my y value also becomes greater than 8. So no. We want the one where it becomes smaller than 8. When it becomes smaller than 8, my x value also becomes smaller than x. Over here, now, it becomes smaller than x, right? But what about the -x? The -x over here. Okay, my x is smaller than x in this case. Okay, fine. Then we check for -x. My x is smaller than -x. No, why? Because now the graph is becoming greater than 8. But what if now we say my x is smaller than greater than -x? Yes, we are right, because -x is increasing. This is the space we are dealing with over here. This space over here, this is the space we are dealing with. So we can say x is greater than -x. Maybe let's say it was -5 and 5. We'll say x is greater than -5, and then x is smaller than 5. This is how you answer these type of questions. This is how you interpret it. You have to check the relationship, how the relativity between the two. You see, if they say for which x values is this graph greater than 8, then you say, okay, I see here you are 8. This graph is 8 over here. I see over here, I see it is 8. What is my x here? My x is -5. My x is 5 here, for instance. No, we're just making an example. Then we'll say, okay, when x becomes smaller than 5 over here, y is also becoming smaller than 8. Okay, no. What if now my x was to become greater than 5? Then my y would also be becoming greater than 8. My y would also become greater than 8. Same here, if x is, you don't say if x is greater than -5. This is greater, this direction is greater. You say when x is smaller, this direction, then my y is greater than 8. Let's just go a little, okay, let's quickly find the equation of this graph. We've got y is equal to ax squared plus q. We have a point, we can take point, we're not gonna take 0.07, right? Let's see, if we take 0.07, okay, let's take 0.07 so that we can find our q, right? No, we can't, we don't have our a, that's the problem. We don't have our a. But we do have our q, because we are told that q in this case is our y-intercept. The graph did not shift left or right. So q is our y-intercept, which is 7. So let's substitute Yeah, but we're still gonna find our q, if you use the 0 and 7. Because if you say y is equal to 7, 7 is equal to a times x squared. Our x is 0 there. Anything multiplied by 0 is 0. So q is equal to 7. Yes. But the question is now, what if you substituted that point and the graph had shifted left or right? Then you are not going to be able to find q, because you would have a complete whatever value, a times a value that's not 0 plus q. Then you would need another point so that you can do simultaneous equation and solve for a and q at the same time. But we are not going to do that here now. For now, let's just work on finding the equation. Okay, our q is equal to 7. We have q is equal to 7. We have a coordinate, which means we can get x and y. It is a that we don't know. Let's use this negative x. Let's say, in fact, you know what? Let's do this. Let's say here we had a coordinate which was 5, 6, yeah, 6. Let's say we had a coordinate which was 6, and in this case our y was not 8. Our y was let me think, not 9, 10. 6 and 10, not 9, 6 and 10. Okay, our y in this case is 10, is equal to our a, we don't know our a, times x, which is 6, right? Squared, 6 squared. Let me look for that squared thing. Where do I find this thing? Squared. Okay, let's say our squared. Oh, there it is. Yeah, there it is. Squared. Squared, 6 squared plus our q, which we established that it is 7. Then we say, okay, 7 move over to the other side. 10 minus 7 is 3. 3 is equal to 8 times 6 squared. What is 6 squared? It is 36. Then we're going to have 3 is equal to, we're generally going to have 3 is equal to, remember you said 10 minus 7 to get the 3 is equal to 8 times 36. You can just write a 36 or 36a, or you can be smart and write it in brackets, a times 36. So it's all up to you. And then you say 3 divided by 36. Therefore, your a is equal to, what is 3 divided by 36? Okay, what is 3 divided by 3? It is 1 over, what is 36 divided by 3? 3 divided, it is 1 and 2. So which means this is 1 over 12, right? Yeah, 1 over 12. Am I correct? 3 divided by 36 is a 12. Wow. Okay, what is 3 times 12? 3 times 12 is 36. Yes, then I am correct, because 3 times 12, or 3 divided by 1 over 12 must give me 36. So yeah, so I'm correct. It's because if you say 3 divided by 1 over, 3 divided by 36 is 1 over 12. Yes, because remember 3 times 12 gives me 36, right? So yeah, 3 times 12 gives me 36, which means 36 divided by 12 gives me 3. Yeah, but 3 is equal to, yeah, 1 over 12, because remember 36 times 1 over 12 is the same as 36 divided by 12. And 36 divided by 12 is 3, because 3 times 12 is 36. So yes, our A is equal to 1 over 2. So therefore, our equation is y is equal to 1 over 2x. Don't forget the squared. Squared plus 7. There's our equation. Yeah, let me just do this actually. Yeah, let me do this. Yes, let me do this. Is equal to 1 over 2 x squared. X squared. Yeah, a is equal to 1 over 2 x squared. Doesn't look so neat, does it? It doesn't, but it's fine. A is equal to a half x squared plus 7. I think it's because that positive number, no, not you, this one. No, not you. You're not that special. This one, yes, I think. Yes, I think it looks much better. No, it doesn't, but it's fine, whatever. Yes, there's our equation. I wrote something here saying that A controls the wideness. It multiplies the squared x value. So which means whatever you get here as your x squared, maybe it was 5x squared, it was 10x squared, it was 15x squared. If you said x squared and your A was, in this case, half, right? No, instead of, 12. Damn. 12. Wow, this is, wow, it's a 12. Well, it's really wide. Hey? No, it's really wide. So what we are saying now is, think of it the way you thought of that other one, the linear graph, the straight line. You see that this controls the x values. It is constant. Your A is always going to be what it is. But what happens is that x squared, as you can see, it is x squared. 5 squared is 25. If we say this is 2, and then we say we want our y, then we say 8 squared, for example, which is 64. Generally, our y would have been 64. Multiply the 64 by 2, you're going to get 128, which means our y would be somewhere there. Now, what would happen is that seeing this graph being like this, let's say we didn't have this point. Forget about this point for now. Let's say this was the graph as it is, and actually, let me do this. Let me do this. Let me say, actually, you know what? Let's be smart. Let's say our y is equal to 8 and actually find the real x values. If y is equal to 8, y is equal to 12 x squared plus 7. 8 minus 7 is 1. 1 divided by 1 over 12, which is the same as 1 over 12. Which is the same as 1 times 1 over 12, gives us 12, right? 12 is equal to x squared. Doesn't work so good, hey? Because now it gives us the square root of 12, which you will need a calculator for that. So, yeah, this equation is really funny. It is possible. Anything is possible in maths, especially if you simplified it. But let's just say this x was 5. Oh, man. Okay, fine. It's disturbing me. Yeah, let's just say, and this was negative 5. Let's say this x was 5 and that was negative 5, right? Now, check where it is. Just check where it is. It returned 5 and negative 5, where y is 8, right? Okay. We don't know our a value again, so let's actually find let's do this. Okay, we're not gonna find the equation of this graph because we need to move down to the questions, right? Check where it is. Ne? Just check where it is. Now, what we are saying now is when your y is 8, your x value is negative 5 and 5 this side. Now we multiply whatever the x was. Whatever the x was that the x was negative 5, negative 5 squared. Negative 5 squared or 5 squared gives us 25, which means our y was supposed to be 25. But because our y is not 25, instead it is 8, then that means, our y became smaller instead of becoming bigger. So which means whatever this is did not make this bigger, it made it smaller, which means this is a fraction. Yeah, this is a fraction, basically. It's a reciprocal, it's a smaller number, smaller than 1. Because if this was 1, it would have been the same, but now it became smaller than 1. But okay, look at it like this. Our y is 8. Let's say our values were something like where x is -5 and 5, our y was 16. Let's say it is where our y was 16. Okay, let me just do this. Maybe over here, you know, y is 16, and we want to know our x values and y values. Now, watch what's gonna happen. Watch. This graph came from here, moved all the way here. Now, in this distance, it shouldn't pass over here, it should pass over there, which means as it goes now, it has to sort of come closer so that it can reach over there. You see, it has to sort of come closer to itself, even over here. Let me actually find something I can use to draw. Let's say it's now coming here. Looks so fat. You see what's happening now? What happened? Okay, this is not, it doesn't look so accurate, but you see what's happening is that now this graph, it is much closer to each, it's like these two lines, they are much closer to each other because they have to reach this higher point. Go ahead, try it on your own, try drawing a graph like this, make your own graphs, and then you will see what I'm talking about. That when you multiply the x values, basically you are saying that the y value has to be greater, which means these two lines, you are basically taking them upwards. And as they go upwards, this point of the graph and this point is going to go upwards, taking all these other things much closer so that it can, you know, that's how it generally looks. That's what it does, the a value. You see, we found the equation and stuff. We did so much already. Yeah, let's already move on to our next thing. You know, now we are dealing with the hyperbola. Okay, let me just quickly erase all of this because now we are dealing with the hyperbola. You know, hyperbola. I don't know what you call it. You know, yeah, many of us, we know it as the hyperbola. You know, we know it as the hyperbola. Is this erasable? Oh, yes. Okay, now we are at the hyperbola. Remember what I said? Y is equal to anything. You can do whatever you want with x. You can put x underneath a line of a value. You can put it as the exponent. You can square it. You can even say y is equal to a divided by x squared if you want to. I don't know what you're gonna get. Play around with it. Substitute, you know, make y is equal to a divided by x squared, and then substitute your x values, you know, plus whatever q. And then for every time you get a y value, you just make it a coordinate, change your x values, play around with it. You could create different shapes. You could say y is equal to a divided by x minus 3, you know, and then you go ahead, the plus q, and then whatever x value, you know, you're going to have to subtract 3. Play around with it on a calculator, you know, play around with it on a calculator and things like that. You could say y is equal to a plus c, which if c is 5 and a is 4, I'm just going to say 5 plus 4 is 9, and then y is equal to 9 divided by x, you know, make it x plus 10, x squared plus 8, whatever you want here, you know, you are having fun. So yeah, y is equal to 8 divided by x. Now this one has an asymptote. For instance, this one, if your q is 0 in this case, your q is 0 in this case because, you know, yeah, let's just say your q is 0. We didn't add, remember, a constant, I mean, the value subtracted or added to the original y values. So in this case, we didn't add anything to the original y values or subtract. So we'll just say it's 0. Then we will just focus on this now because we don't care about 0. Y is equal to 8 divided by x. Where are you going now? Y is equal to 8 divided by x. So let's say our a was 5. Our a was 5. Our a was 5. Y is equal to 5 divided by x. Now watch what's going to happen. According to maths, you cannot divide a number by 0. Anything divided by 0 is undefined. So in this case, our asymptote is going to be 0. X is equal to 0. This line over here is our equation of the asymptote, the black one. This line is an asymptote. This graph, no matter how close it gets, it will not touch it, which means you can draw any number here as close to 0 as possible. You can even draw 0, you can even do this. You know, say y is equal. You can even say, you know, y, you know, is equal to whatever the a value is divided by 0,0000, all these zeros and stuff like that, you know. Yeah, y is equal to, let me just do this, so that yeah, you can even do this, you say, yeah, y is equal to, and then you write 1. Yeah, come on. You can even do this. You see, you are trying to get closer to 0. But the point is, you mustn't write 0, because the moment you write 0 there, it's going to be undefined. You can add as many zeros as you want, and you can even add 2 or 1 or whatever that you want to add. Whatever that you want to add, or whatever, it's all up to you. Remember, I said this is maths. We're about to start with our questions soon, in like an hour or so. Remember, I said this is maths. You can do whatever you want, but the moment you write 0, it's undefined. So you're trying to get a number as close to 0 as possible. Well, good luck, but I don't think you will succeed, but good luck, because they say it's infinite when I did my research last time, so yeah, you can try get closer and closer to 0, or for all you know, you can try and get further and further. No, wait, you're trying to get closer to 0, right? Closer and closer. You can even say this is negative y is equal to a divided by negative that, but y is equal, okay, let's say our a here was 5. Y is equal to 5 divided by 0, comma, all of that. Type it in your calculator right now. You will see you are going to get a value. Let me also type it in this calculator quickly. We are saying what? Y is equal to a, which is 5, divided by 0, comma. I'm not really going to count all those zeros. I'm just going to count the, yeah, whatever. You see, I get 5, comma. I don't know how many zeros these are. This is a phone, by the way. I'm not using a scientific. Then I get 5e28. Maybe E means infinite or whatever. I don't know what it means. But yeah, that's why when they tell you about this graph, they say it gets closer and closer to the asymptote, but it will never touch the asymptote, which means you can get closer and closer to 0, but your x value must never be equal to 0. In this case, your domain is x is not equal to 0. Yeah, x is not equal to 0. And then your range is y is not equal to 0, because, your y mustn't be 0. 0 is equal to what? 0 is equal to 5 divided by what exactly? What are you saying? You see, no, wait. No, your y can be 0 actually, if you think about it. Your y can be 0. This over here, no one said it can't go over and intersect it. Your y can be 0, but remember now we said there's no q. This graph was not shifted up or downwards. We are only left with y is equal to a divided by x. And if we say our a is 5, we want our y to be 0. The question is, 5 divided by what will give you 0? 5 divided by what? What can you say? 5 divided by what? Or 5 multiplied by the reciprocal of what gives you 0? My question to you is, what is the reciprocal of 0? Because remember, according to maths, you can multiply by the reciprocal. So let's say you are saying 5, you're going to say 5 divided by 0 is impossible. So you want to say, I'm going to look for the reciprocal. What's this? Okay, you're going to say, I'm going to look for the reciprocal. So 5 multiplied by, okay, I know that any number is over 1. So why don't we say 1 over 0? Again, as I said to you, any number divided by 0 is undefined. 5 times what exactly? 5 times 1 divided by 0. Go on your calculator and type 1 divided by 0. Let's see if we'll even get an accurate answer. One, what's this? 1 divided by 0. What? It's giving me some none, or what's this? Yeah. Try it on your calculator. It will return a math error again, because anything divided, you can't divide something by nothing. Okay, let me ask you a question. Right now in your hands, how many nothings are in your hands right now? How many? Okay, whatever that you are holding, put it down. Just put it down. and hold nothing. Now, how much nothing are you holding? Can you give me the answer? Can you tell me how many nothing is there in that nothing? How do you count nothing? You know, so you cannot divide by zero. You can't. Even if you try to be smart, you say, you know, I'm very smart multiply. In this case, your y is zero. I mean, your y cannot be equal to zero. Yes, your y can never be equal to zero. Your y cannot be equal to zero in this case. So which means it can get closer and closer to zero. You can type that 0,000, a million zeros if you want, and put one at the end, but you will not touch zero. You cannot get closer to zero even here, you know, unless if we said y is equal to all of that, and then you say, okay, add 5 to everything, then you will see your y cannot be equal to 5. The reason why now, if you say add 5, your y cannot be equal to 5 is because if this is 5, positive 5, and you're saying y is equal to 5, you are solving for x. 5, move this over to the other side, minus 5 is 0. 5 minus 5 is 0. 0 is equal to a divided by what? Again, a divided by what? Or a multiplied by 1 over what? Again, a divided by what? If you say 0, 0 is equal to a divided by what exactly? That's why there's what you call an asymptote. A divided by what? Divided by 5? If your a is 5, 5 divided by what must give you 0? Or 5 multiplied by 1 over what exactly? 1 over 0? Oh, no. You can't say 1 over 0. 1 over what exactly must give you 0? Okay, let's say 0 is equal to a divided by x. A is equal to 5. Let me show you something. A is equal to 5, right? You are saying, okay, I'm very smart. I'm going to move this x that side, and it's going to become a multiplication. 0 is equal to 5 divided by x, right? 0 times x, anything multiplied by 0 is 0, because if I've got 5 nothings, I still got nothing, you know? If there are 5 empty baskets and you put them together and then you put them upside down, nothing will come out. Y, which you are trying to solve for, multiplied by, 0 multiplied by this x is going to give you 0. 0 is not equal to 5. Yes, and that's it. Let's just go briefly on what we went through. These are just functions. Go through them. We are going to do question papers just now. You know, the gradient can be positive, negative, 0, or undefined. This is the linear graph. The gradient, I'm talking about the x value. I'm just saying that, you know, you can get a gradient to be 0. When it's undefined, it is where maybe x is equal to 5. For instance, it's a straight vertical line. We say the gradient is undefined. Otherwise, in this case, if it's horizontal, it is 0, because y is equal to nothing times x. You don't multiply x with anything. If y is equal to 5, don't multiply x with anything. Don't multiply it with anything. You know, y is equal to 5. X times what? X times, don't, you know. So in this case, your gradient will be 0. Let me show you something. Let me just show you a trick, man. Let's say this was y is equal to mx plus 5, right? And we said our gradient was 0. Y in this case is equal to 5, right? How is it so? Because for x, if you put 5, anything multiplied by 0 will return 0. And 0 plus 5 will always be 5. So y is equal to 5, you know, and things like that. You can't say x is equal to 2. The gradient of y is undefined in that case, because because you know, you don't have any y values basically. So the gradient, it's undefined, you know, unless, even if you try to say it's an inverse function, x this, you know, no, even if you try an inverse function, you don't have y. That's the thing, which is, you'll see it in grade 12. It is a straight line. A linear graph is a straight line. They can ask you, are these points called linear? One rule about functions, if you substitute any value on x, it will always give you y value. If they give you a coordinate and you put it there as m, and maybe let's say m is 5 and x is 5, if they are not equal to each other, then that means that point does not lie on the graph. So if they ask you, maybe they give you coordinate 2 and 5, are they collinear? Substitute 5 here, which is the y value, substitute 2 here, which is the x value. If they are equal, then that means yes, they are collinear. If they are not equal, they are not equal, then you say, maybe let's say this was 3. 3 is not equal to, maybe let's say 8. 3 is not equal to 8, so they are therefore not equal. You see, yes. This is u, y, this y means u, and then over here, maybe let's say it was fail. You are not equal to fail because you are not going to fail maths this year. You are not going to fail maths. If the gradients of two of these functions are equal, then the two lines are parallel, having a difference in the c value. This is very important. If the gradient is 5, y is equal to 5x, and you change the x value, then those two lines are parallel. This is how you make parallel lines. You just have to make the gradient equal. As long as the gradient are equal, if the c value is equal, you say 5 for both of them. Maybe let's say y is, you try to get smart and say, what if the c value is not different? Let me show you what it's gonna do. If you say the c value is 5 for both of them, and the gradient is 2 for both of them, then your equation for both of them is y is equal to 2x plus c. Now, 2x plus c and 2x plus c, there's no difference in that. Y is equal to 2x plus c. Even if you write it here, it's still the same. So it's one line, you know. So having a different c value, this is how you make parallel lines. The gradients have to be different. And you will also learn how to make them perpendicular and things like that, you know, as time goes on. But for now, if the gradient is the same, parallel lines, this is that important graph, you know, this is a very important graph. This graph is very important, parabola. Every y value returns 2x values. The reason for that is because if the square root is 5, negative 5 times negative 5 will give you 25. Positive 5 times positive 5 will also give you 25. So if your x is negative 5, remember this is squared, your x is squared. So negative 5 squared, which is negative 5 times negative 5, gives you positive 5. Also, positive 5 squared gives you 25. Oh, yeah, 25 here. So your y is 25. Then your x can be positive 5 or your x can be negative 5. Doesn't matter. This is why when you do your thing, you sometimes do the difference of two squares and things like that. Looks like time is running out. The turning point is either minimum or maximum. The reason why is because the coefficient of x, remember the ax value thingy, you know, influences the return value of y, you see. But then x value always returns a positive answer. Remember, as I explained it here, that even if your x value is negative, you'll always get something positive. If your y is negative, negative times positive is negative. So if your a is negative, you will always get something negative there, and then plus that q, which can make your y value positive. But you know, yeah, but because that always returns a positive, the coefficient will make it either always be negative or positive. So let's say there was no plus q and you decided to increase it. Then maybe let's say you said, okay, now my x is 12, 12 squared, which will return 144, or negative 12 squared, whatever it is, which returns 144. 144 times negative whatever a gives you a negative number. Just like that, the higher you go, the number will always be negative, which is why the parabola will look like this, because you are going high in values, but it keeps on taking you lower and lower. However, if it's positive, you know, it keeps taking you higher and higher. You know, it keeps on taking you higher and higher. Okay. Okay, yeah, that's it. You know what's going to happen now is that yeah, what's gonna happen now is that you see, we were supposed to be going through question papers, but I will make another video for you, sending you the one where I go through a question paper so that you may watch this video. It is wonderful that at least we managed to go through this. Some lessons you will get them without participating, and then some lessons you will get them by participating, you see. But any questions you have, you are more than welcome to ask any questions. I hope you enjoyed something let's just quickly analyze something about these questions before time runs out. Before time runs out, we're about to run out of time. Yeah, let's just quickly go through a question that has functions in it. Let's just, okay. No, it has a hyperbola. I don't want, I want the question that shows a function actually. I'm lazy to draw. Let me show you. Let's, here's this thing down. Yes, here's the question. Here's the question. For instance, sketch it. Sketch it. The equation. Come on. The equation there. Here it is, and things like that. The value of Q. Write down the value of Q. Q, it is 1. How do I know that Q is 1? Because over here, this is a hyperbola. I know that, okay, a hyperbola looks like this, because of that reason that K divided by X, the fact that we are dividing by X, I will explain why it looks like this. Oh, it's because this value, if it's positive divided by negative will give you positive divided by negative will give you negative, right? So if you're saying your X is negative over here, positive divided by that negative must give you a negative Y. And then if you say your X is positive, positive divided by positive must give you positive. So if your X is positive, even the Y must be positive. That's hence the quadrants. But okay, the Q is Y, domain of F. X is not equal to 0. That's it. X can be anything, but it mustn't be equal to 0. How do I know that? Because X is an asymptote. If X is equal to 0, you can't divide by 0. So yeah, that's how I know that. And then, sorry. And then let's just go further down. Equation of the line of symmetry of F. The equation of the line of symmetry, the gradient is always 1 or negative 1. But in this case, it's a positive gradient, which means it's 1. But it has to pass through this asymptote. That's what's very important. It has to pass through the asymptote. It has to pass through, this coordinate here, which is the coordinate of the two asymptotes. In this case, you have your X is 0 and your Y is 1. That's your coordinate. It has to pass through both asymptotes. It has to intercept the asymptotes, you see. And yeah, so that's your coordinate there, 0 and 1. Substituted, equation of F again, equation of F. Let's see. You have a coordinate in this case because, no, you have, what do you have? What do you have actually? What did they give you? They're just asking you to determine the equation of F. They gave you Q because remember you said Q was 1, right? And then you know that the asymptote in this case is 0.